Well, let's go ahead and dive into our lesson then. We'll go through one example here and then we'll take attendance for anybody who's trickling in. What we're studying today is we're studying the multiplication algorithm. The standard algorithm of multiplication is pretty complicated, and we are going to dive into the building blocks of the standard algorithm and see how it comes out of work that we've done previously using the distributive property and multiplication by 10, base 10, and the addition algorithm. So there's three parts to that. So we use the distributive property, we use multiplication by 10, and the addition algorithm. So what we want to do is we want to diagram the multiplication process using base 10 blocks or a manipulative that's concrete. Okay. Okay. So I'm going to try and connect my pen again back to my iPad. It seems to. Uh-oh. Yeah, somehow my pen isn't working, so we'll go ahead and try and do that. Yeah, so with your base 10 blocks, so I'll write this down in a minute here. I'm going to share my screen with my iPad. Okay, so I have my base 10 blocks here, and I'm going to arrange them in a way to show the multiplication of 24 times 3. 24 times 3. So you have 3 groups of 24, right? So what they do is we're going to kind of put these aside here. And I'll model them using a rectangular model, an area model, where one dimension of a length is modeled by one number, let's say 24. So you're modeling here, I got 22 out in a line. Okay. So if I'm going to model 24 times 3, I need to have 3 groups of 24, or 24 groups of 3. And I do my 24 in this way because I have 2 bars, here and here. And those 2 bars represent 10 units. And those 10 units are hard to draw singly, but that's why we put them together. Okay. So I have 24 on here. We need 3 groups of that. Okay, 24 times 3 and 3 times 24 will give you the same answer. So in order to, instead of drawing another one under it, or putting manipulatives under it, I'm going to put 3 on the side here. Okay. So 3 of these units are going to go on the side. And I've gotten one length here on the side for 3 units. That will be my 3 groups. And here's the rest of the 24. But when you fill in your base 10 blocks, you kind of disregard the top line and the side parts. And whatever's inside here will be an area, a product. Okay. So if I take one rod and multiply by 1 unit, it's just one group of that one rod. Okay. And I continue filling it out here. Here's my second one, and I get some more units here. Okay. Right, so there's my second row. Okay, so we continue in this fashion. We fill in the rows according to how many we need. We need 3 rows of 24. Okay. Go ahead and finish that out in your own diagrams and see what one comes up to. Do that. Finish those out as your diagram, and then find the total. How many total squares are there? The units there. Now we're working. So what I have is, I'm going to share my screen now. We got 24 times 3. It's for multiplying whole numbers using the standard algorithm. The first example is 24 times 3. Okay. And this is an area model. We with base 10 blocks. So we're going to do this with base 10 blocks first. Okay. So 24 times 3, we have 24 groups of 3 or 3 groups of 24, however you want to look at it. And what we do is we diagram the 24 and the 3 as we go on here. So with the 24 and the 3, so here's my, oops. When you use base 10 blocks, you need to use a key. So let me put the key in here. And we're going to use them as their face value, like normal, since we're doing whole numbers. So this cube is the same as 1,000. The flat is the same as 100. The rod is the same as 10. And the point dot is the same as 1, the little cube. Okay. So those are our base 10 blocks. We need to draw out 24 times 3. So I put my 2 rods here on the top row. And I put my 3 on the side. So there's 24 times 3. And what I'm going to do is I'm going to fill them in according to each column of place. So if I have here, and this part right here is 1, and then this is a rod. So that's 1 and 10. And 1 times 10 makes 10, or it will be another rod. So as you go down here and as you go here, you fill it in, you get these rods. So I'm going to label this one. It's my 24. 24 can be thought of as 20 plus 4 as well. Okay, so I'm just going to break them up a little bit. And that's my 3. Okay. Now we're going to draw them in. And as I fill them in, I notice that, see, we have these two again, these 2 rods, and then these 2 rods here, and these 2, another set of 2 rods here. Now I'm going to look at the intersection of the points here. So like this point and this point, this endpoint will intersect with this point here, and they will actually make another point because they're 1 times 1. So the little cubes are still cubes. So that will be the case through all of this row, and all of this row, and all of this row. All right, so hopefully everybody's filled out their base 10 blocks this way. So it's good to have something like concrete to move around. You can see how the groupings work. Okay, now that's the first way. We know the total right here. We're going to calculate the total in a couple of ways. 3 ways. Okay. And when we group them together, we'll have a group here. We take all our 1s and group those together. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 1s here in this group. They will make another rod. And when I add up the 1, 2, these ones here, the rods, we have 1, 2, 3, 4, 5, 6, 7. Okay, so there's 7 rods. All right, so I have 72. 7 rods, 2 leftovers. Okay. Let's go, we're going to compare this to something a little bit more abstract, which uses numbers. So I've used concrete model with my base 10 blocks. I used the drawing is another level of abstraction with the table on the iPad. And then will use numbers. Now we're going to use the actual digits in a couple ways. First way is called partial products. And we are doing 24 times 3. Okay. And we're kind of like the partial sums idea with addition. We're just not going to worry about carrying or anything like that, or regrouping. We'll do 4 times 3 first, and we'll get 12 with that. Then we'll do, oops, use red. And then we'll do 20 times 3. I've already taken care of the 4 times 3 right here, but then when we go here, we do 20 times 3 is what we're actually doing. And 20 times 3 is 60. Okay, so this one right here, again, to recap, is 4 times 3. Oh yeah, and I wanted to divide these up. Hold on a second. I just thought this will be easier to look at. 20 plus 4 times 3. Because partial product separates each number into its tens and ones, or hundreds, tens, and ones. Now I can see these products a little more clear. 4 times 3 is 12. 20 times 3 is 60. And I'm going to add those together to get my 72. And then I'm going to do the standard algorithm. So we all know that one. 24 times 3, we write it vertically, like the partial products, but it's more compact than the partial products. Four times 3 is 12, and then put the 1 above the 2 to do that one. So I'm going to do it like this. And then my 2 times 3, which is going to be 2 tens times 3, is 6, and add the 1 is 72. So much more compact than something like partial products or a diagram. Now, where are these connections? We need to make connections between them. In this problem here, the partial products, the 12, is from 3 times 4. And the 60 is from 3 times 20. Let's go ahead and see how they connect back up to our base 10 block model. Do purple connections. My 3 times 4 is the first thing I did in partial products, and it's the second thing I did in the base 10 blocks. But this right here is the first thing that is done here. We can label that as the first thing if we wanted. Okay, number 1. This is step number 1 down here. Okay, they're the same. They find out what 3 times 4 is. And number 2 step. We wanted to find out what 3 times 20 is. So that's number 2 down here. And that would correspond to number 2 up here. Okay. 3 times 20 is this right here. What we have next is where we were grouping these here. So we have the 6 and the 1 right here. Oops, that's erased here. And the partial products is where we group together. The 1 from the 12 is 110 from the 12 here. And the 3 groups of 20. We can go and do this kind of thing. We group this together and with that one. That's step number 3. Okay. And then the last step was to add them all together. And so the total from everything, I'm going to use some more room here on my base 10 block model. I'm going to take these 2 right here, along with what's from 3. 3, just to help, let's close in back in, this is like 7 times here. 7 tens and 3. The 2 ones that are left over, we'll go with the 7 tens, and we'll have an answer of 72. That's where our answer comes in. That's step number 4 when you add them together. Oops. All right, any questions so far? All right, so in summary, the standard algorithm, we can write the steps out. So number 1, let's see again. Yeah, so this is going to be overall steps. How we're going to connect them all. So number one, we took three groups of four. Or 3 times 4, that was our first step. Then we make that 12. And so when we're doing this, we record the 1. No, the 2, sorry. We record the 2 from the 1s because there's no more 1s going to be made. And save, since it's 12, and save the 110 from the 12. To combine with the other 10s. From the 3 times 20. We haven't technically calculated that yet. So that's number 1, step number 1. So that's why it's in red, 3 times 4. Now step number 2, we do 3 groups of 20. If you think about what that is, or 3 times 20. And we know that 3 groups of 20 is 6 tens, same as 6 tens. Number 3 is when we combine our tens together. We combine the 110 from 12 and the 6 tens from the 60, or the, from 60, to give 7 tens. Okay. Are we following so far? Good. Then step number 4 is where we added here. I'm going to add the 6 tens, or we can just say 60, it's fine. Oops. And the 12. To get the 72. Okay. That's our answer. Okay, many questions? All right, so standard algorithm, we have pictures, 3 groups of 24. We have partial products, which help us with an intermediary step abstractly. So we can take 4 times 3, and we're going to do 20 times 3 as well. Okay. So that's like our first example. We did a simple 2-digit by 1-digit example. In the partial products works because we are doing 24 times 3. And this is the mental math connection. Because we've been doing this for all of our mental math. 24 times 3 is equal to 20 plus 4 times 3. Okay, and you can do from there you can go to distribute the 3 to the 20 and the 4. Okay. And then we have 20 times 3 plus 4 times 3. So that's why we're breaking it down into the partial products. This is the distributed property that helps make it happen. So we are very grateful for that one. The multiplying by 10 helps us get 20 times 3 as 60 instead of just 2 times 3 as 6. Okay? And then we add them together right here. We add them together as the other key component to multiplying with the standard algorithm. So let's do another example. I want to get a little bit more complicated here. And we'll do a 2-digit by 2-digit problem. $35 times 16. And 35 times 16, we're going to multiply those together, and we'll see how things work out. We'll do it with the same processes. The first one we'll do with base 10 blocks. Again, we'll have the same key. Where the block gives 1,000. Oops. The flat gives 100. The rod gives 10. The point gives, the little cube gives 1. Now that's our key. We want to model 35 times 16 again like an area model rectangle, where one dimension or like a length is 35 and then the other one is 16. So the top number I usually put as the horizontal. So I need 3 10s. Okay, so I'm going to draw like my little grid here. A little bit shorter. 3 10s and 5 1s. Then I'm going to do 1 10 for the 16 and 6 1s. So we diagram them using a graphic organizer. And then we kind of move down and move to the right by combining these together using our base 10 blocks. Now our rods here are 10 times 10. And so these ones I'm going to diagram as a flat, because this one combined with this one, we go this way and down that way, makes a 10 times 10, 10 groups of 10, which is 100. Same story for this one here. And this one here, kind of filling them in. Okay, remember that a rod and a unit, so this one and this one, combine together. So we kind of carry that through here and then bring that one down. That one doesn't have any width. This one has some height. So we got that one rod there. So a 1 times a 10 is a 10. So I'm going to do this for each one of the ones. Okay? And same thing with a 10 times 1. So those are filled in there. And now I'm going to consider what my unit cube and unit cube is. So if we bring this one over this way, this one down this way, we'll have another unit cube here because this is 1 times 1. Okay. So fill in those units down here. Okay, so we got them all filled in, coming down and coming to the right. We need to group all our objects according to the base 10 rules and structure. But first, what did we do when we multiplied these together? Well, actually, we'll make that connection at the end. So we will group them according to base 10. I'm going to combine as many little cubes as I can to make as many rods as I can. So each little cube has 5 for its row. So we can combine these together, make 10 cubes. Combine these together to make 10 cubes. Combine these together to make 10 cubes. So we combine their cubes together because if I start combining my rods together, then I might have some left over. Some cubes left over to regroup into a rod. So I'm not going to regroup all of my rods first. I need to start from the littlest unit going back up. And that's kind of the approach, the efficient approach for the algorithm. So we combine all of those together and you get 3 new rods with no leftovers. Now there are rods here, there are rods here, and there are rods here. We need to combine them all together to groups of 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here's a group of 10 rods. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is another group of rods. Another group of 10 rods. Okay. Right. And I have 6 rods left over. Okay. And then my 3 flats, those are the 3 flats. So when all is said and done, we have 3 flats. Let's see. We have 3 flats, and we have 6 rods, and we have no leftovers.
Don't our 2 groups of rods turn into 2 flats?
Oh, yes. I did group them together. Thank you for catching that. So I really don't have 3 flats, I have more than that. These rods, when I group 10 of them together, become a flat. And same thing with this one here. Okay, now we have 5 rods, or flats, 5 flats, there we go. Okay. So this is what we have, 560. With multiplying with the partial products, I was wondering if somebody could guide me with that one. Anybody have a volunteer? Maybe anybody. Okay, I'm going to give a stab at partial products. Partial products, you're just to multiply each 1 digit by 1 digit multiplication, and you'll write the answer down, and we'll label them.
So I can at least tell you how to start. It would be 30 plus 5 times 10 plus 6.
Great. 35 becomes 30 plus 5 times 10 plus 6. Okay. And we'll go ahead and multiply each one of these partial products, like 5 times 6. Kind of like the standard algorithm, but I'm going to write down all of them. And the 5 times 6 is because of the red unit cubes. Okay? So there's 30 of those. Okay, so you just kind of do this one first, and then you're going to go here next. 6 times 30. 6 times 30 is 180, is from these green rods. So we have 6 groups of 3 rods, which is 18 rods. But we're going to do 180 because each rod's worth 10. Now we're going to go with 10 times 5 and then 10 times 30. 10 groups of 5 and 10 groups of 30. The 10 groups of 5 becomes 50. Okay, so those are still rods. Those are these ones here. And then we have 10 times 30, which is 300. We'll add these together. So when you add things in the addition here, we are also kind of combining our groups together for the rods. So we're going to add them up. 0, and 3 and 8 is 11, and 5 makes 16. And that is 1 and 1 makes 2, so it's 5. So here's where our 560 comes from. Okay. So this one right here is going to be from my 6 times 5. This one right here is going to be from my 6 times 30. This one is going to be from my 10 times 5. This one is going to be from my 10 times 30. Partial products. The connection to the multiplication algorithm with these partial products and the standard algorithm, why can we do this? Well, we can break them up, and what we're doing is we want to make it easy to multiply. Notice that each one of these is 1 digit by 1 digit multiplication. Okay, 6 times 5, 6 times 30. 10 times 5 is the 1 times 5, and then 10 times 30 is 1 times 3. Okay? Single digit multiplication, and then we use the tens, multiplying by 10 to shift things as we need. So this one right here, for example, the 6 times the 3 made the 18, but this 0 goes with that 0 there to shift it over to the proper place value for 6 times 30. Okay. Same thing with these here. The 1 times the 3 is the 3. And then the zeros here may put it for over to the hundreds place, so that 3. So those are important. Shifting and 1 digit multiplication, that's why we do it. We'll keep those there as a reminder. So pretty powerful stuff. We break it down to, because it's easy. So here's the math equation that shows that this is possible. We broke, for the partial products, we broke down into 30 plus 5 for 35. And for 16, we broke it down into 10 plus 6. What I'm going to do is I'm going to use the distributive property, and I'm going to take this whole thing here and distribute it to the 10 and the 6. And so this is a little bit about why it works. 30 plus 5 times 10 plus 30 plus 5 times 6. Okay. And then I'm going to use distribution from the back to do the rest of it here. Okay. So that's going to be equal to 30 times 10 plus 5 times 10 plus 30 times 6 plus 5 times 6. So notice that these are the exact partial products from our partial products via the vertical way. It's here, and so those are all connected there. This is why it's okay to do partial products. Vertically, it helps us make the jump to the standard algorithm a little bit shorter way. And so what we have next is the standard algorithm. (35 times 16). Again, we need to value our standard algorithm as compact. So 5 times 6 is 30. 6 times 3 is 18, plus 1 is 20, 3 is 21. Now we put a 0 down because why are we putting a 0 down? Then we start doing the 1 times 5, 1 times 3.
The 0 is a placeholder because we're working with tens.
Good. Now, you're working with tens and it's actually a value there. Like, well, it's a placeholder for a value. Some people put like different things like an X or a space or different things like that. So don't do that when you teach because you are losing the meaning about this number. Okay? This number here actually comes from somewhere. What is, and the standard algorithm has two partial products in it. Okay? If you do 2-digit by 2-digit. Okay? So it is like a partial product. So where does that row come from, the 350? What am I multiplying by to get 350?
Isn't it because you are now working with the tens unit, so it'd be that you need to put a 0 for the ones because you're working with the tens?
Okay. Good thought. Does anybody have, does everybody agree with that? You guys agree? Okay. So yeah, that's good. That's a good thought. You're working with the tens place because you're doing 10 times 35. That's what that partial product is. 10 times 35. You're taking this 10 and multiplying by 35 here. You ignore the 6 in that whole row. Now, anything times 10 has a 0 at the end, right? So when we put the 0 in there, we're just thinking about 1 times 35 after that. That's the 10 times 35. So let me move this part in here. Because that was our answer. Where does this row come from? What did I multiply to get 210 there?
6 times 35.
Right, you're only considering the 6 times 35. You're ignoring the 10 for now because you'll take care of it later. Okay. So the 6 times 35. This right here is the same as the partial product 6 times 30 and 6 times 5 right here. Okay. This 10 times 35 is the same in the partial products as 10 times 30 and 10 times 5. So the algorithm takes these partial products and condenses them. So those are the connections that we can make between the standard algorithm and the partial products. Let's take a look at our base block model for one more time. We have this group right here. Okay. This is going to be the 6 times 5 group here. Partial products. Number 2. This one is my 6 groups of 10, 5 groups of 10. 5 times 7. And this one right here is the 3 groups of 10. No, 30 groups of 10. No. 3, 10. Yeah, because this top part is 30. So 3 groups of 10. 30 groups of 10. Here. Okay. And then this part right here is my 6 groups of 10. 6 groups of 30. There we go. Okay, so you can see the different parts of each approach, how they connect. So that's our goal. You can describe that in words, kind of like what we did with the first one. Any questions so far? All right, so we did the multiplication using several forms, concrete model or / drawing, and then we have our 2 ways to do it with abstract models. We use just numbers. One is partial product, where we can make connections to the standard algorithm and back to our diagram. So there's the partial products here. Notice that these are also the partial products. And they come about by the distributed property. Okay? And we showed that right here with the partial products. Okay? This is the distributed property help. The distributed property we used twice. Notice that we used it forward and backwards. And this is one of the reasons why the shortcut FOIL works. Be a member of FOIL from algebra. So the base block model is a way to show an area model or an open box method. So I'm going to multiply something using another method, and it's called open box. We'll use the same number so we can make some more connections. 35 times 16 using the open box method. So it's a lot like the area model. And this is the one that I've seen most with multiplication with my kids as they learn how to do it. They use their curriculum used the open box methods or an area model. So I'm going to draw a box. Okay, so it's similar to what we've done before with the base blocks. And we need to divide, again, our 35 and 16 into 10s and 1s. This on the top I did 35, so it's 30 plus 5. Now the 35 is going to technically run along this dimension here. So there's 30 here and there's 5 here. But I'm going to combine them together to just make a line. This whole line here represents 35. So I'm going to divide it off where my addition sign is. So I can have 30 here on one length and 5 on the other. The next one is 16. Okay. And then we get another division here. This is the 16, so 10 plus 6. 16, 35. Now breaking them into single digit by single digit with some tens is the way we did the algorithm, but it makes the numbers easier to work with if we break them up to the tens and ones. So now we're going to do our kind of like our area model, where we'll fill in each of these area of these boxes. Now the area of this one is going to be 30 times 10 units because I'm just focusing on the 30 and then the 10. This one is going to be 5 times 10. This one is 30 times 6. This one is 5 times 6. Okay, so you see how you break up a whole rectangle, which you want to find the area of, into certain parts to make the multiplication easier. Now what you're doing is you're going to add them together. And let's go ahead and use our standard algorithm. It says that we had multiplied 6 times 35 and then 10 times 35. Question? So 6 times 35 was the top one. So that's this part right here. If I combine these two parts together, in my partial products, that'll connect up to this first one right here. If I connect these two together, that'll give me the same calculation as this right here at the bottom row. Okay. So each of these individual partial products connect to the partial products, but if you combine a set of two together, then they actually connect back to the standard algorithm. Okay. So we want to add them together, and we're going to go ahead and use Ripple. So we're going to add these two together. They make 30 plus 50. And that makes
It's 300 plus.
300 plus 50. So because you wanted to make the 350 at the bottom one. Good. And then I'm going to add these two together. That makes my 180 plus 30. And that was 210. And then both of them together add up to my 560. So that's the open box method, where you can add them up anyway. You don't have to like make these lines to connect, but you just separate it into the partial products using more of a diagram instead of just numbers. Any questions so far? Yeah. All right, so in the homework, you can multiply using these methods of base 10 blocks, partial products, and the standard algorithm by using a description like I did in the first example. By making connections as in the first example, or you can talk about the connections like I did in the second example, where I show where the partial products go to the standard algorithm and to the base 10 blocks. Okay. So those connections are important to make so that you know what's going on with the standard algorithm and not just doing math blindly. All right, so after I've talked about all of these things, which one, we're gonna do an example too for the last 10 minutes. Which one is the least clear for everybody to try? What do you guys think? Which one's the least clear so far? Which method? We have open box, partial products, standard algorithm, and base 10 blocks. And which one is least clear that we could just do another example of? While you think, I'll take attendance. And so forth like that. All right, you guys are a quiet bunch today. All right, should we do another open box method? Do one more open box method and then we'll call it a class. So we're gonna multiply, let's do a 3-digit one, 345 times 47 with open box. The open box is divided up by place value. And so I'm thinking about this as 345 times 47, 300 plus 40 plus 5 times 40 plus 7. And so we break up into place value. We're going to draw our box.
Your iPad's not showing, Dr. B.
Okay, because I went back. I need a share screen. Thank you. Okay, how's that? Okay, since I have a 3-digit number, it's a long one, 345 times 47. Down just a bit. We're going to take the first number, put it along the horizontal of the rectangle. So I break it up into 300 plus 40 plus 5. So that's my 345 right here along this dimension. And I'm going to divide it up like this. And along my other dimension, which is the vertical part, we're going to do 47 So we'll do 40 plus 7. That makes my 47. Make a division this way. Now in the middle, I'm going to multiply my numbers together. So this is 300 times 40. That's equal to 12000 and 12,000. Notice that I could do the single digits, 3 times 4 to get 12, and then I put in all of the zeros after it. So that's what's great about this way of approaching the problem, is that you can multiply the 1 digits together and then use the powers of 10, multiples of 10, to push all the zeros together. This one is going to be 300 times 7, 2100, and 2100. 40 times 40 is my next one. 4 times 4 is 16, put down the zeros. Then we have 40 times 7 equals 280. 40 times 5 equals 20. Go with the 0 at the end because of that other one on the 40. And then we have, hold on. I wanted to write it as 5 times 40. And this one right here is going to be 5 times 7, which is 35. And so we add up all of those partial products. $12,000, 1,600, 200, 2,100, 280, 35. And when you add up all of these numbers, you have your answer, which is 5, 11, 7, 9, 10, 11, 12, 15, 3, 4, 5, 6. 1, 6, 5, 1, 5. Okay, so there's the open box method again. What's great is that we're multiplying this way, but then we also keep our middle and then one of our dimensions, the top or the side, and we can do division that way too. So that's how I've seen my kids do division, but we'll get to that later. Any questions before we depart?
I'm not sure that it was 15. I think you added the 3 from 35. Because in the hundreds place, you have a 6, a 2, a 1, and a 2.
Ah, the hundreds place. Great. 6, 2, 8 plus 1 is 9 plus 2 is 11.
Don't forget the 1 at the top, which would make it 12.
Make 12. All right. Just making sure you guys are on your toes, listening to the end. So anyway, thank you so much. And I hope you guys have a wonderful Monday.
Thank you.
You're welcome.
Thanks, Dr. Beam.
You're welcome. Okay, any questions, Mary Dee and Lindsay?